Imagine if Mars were our main planet. If humans had evolved and lived on Mars instead of Earth, the course of evolution, history, and technological development would have been significantly different. In this series, we will explore some key considerations on how such a scenario might have unfolded. Part 1: Physical and Biological Adaptations. If humans had evolved on Mars, their bodies would have undergone a series of adaptations to thrive in the distinct Martian environment. The lower gravity on Mars, about 38% of Earth's gravity, would have had a significant impact on human physiology. Over generations, these adaptations would have gradually shaped the Martian human population into a species uniquely suited to their new home.
Hey! The low gravity has made my body to expand in all directions.
In the context of bone density and muscle structure, we can imagine that Mars' weaker gravitational pull would have led to reduced stress on the skeletal system. As a result, Martian humans might have developed lower bone density compared to their Earth counterparts. While this adaptation could prevent the bone and joint issues associated with prolonged exposure to high gravity, it might also present challenges when traveling to Earth and performing physically demanding tasks in Earth's stronger gravity. And when it comes to lung capacity and oxygen utilization, with Mars having a thinner atmosphere composed mostly of carbon dioxide, Martian humans would have evolved altered lung structures to more efficiently extract oxygen from the available gases. Their respiratory systems might have developed larger lung capacities and improved oxygen-carrying capacities in their blood, allowing them to extract sufficient oxygen for bodily functions despite the atmospheric differences. Mars receives about half the amount of sunlight that Earth does, due to its greater distance from the Sun. Martian humans would likely have developed adaptations in skin pigmentation to counteract the reduced UV radiation. Additionally, their skin might have developed enhanced mechanisms to protect against the harsh solar radiation and cosmic rays that penetrate Mars' thin atmosphere, reducing the risk of DNA damage and radiation-related health issues. The lower sunlight intensity on Mars would have influenced the evolution of eye structures. Martian humans might have developed larger pupils to capture more available light and potentially enhanced night vision. Conversely, their eyes might have been more sensitive to sudden bursts of sunlight, which could have helped protect their retinas from the occasional intense solar flares that reach the planet's surface. Part 2: Technology and Infrastructure. In a reality where Mars was humanity's main planet, the technological landscape would have been uniquely shaped by the challenges and opportunities presented by the Martian environment. Given the fundamental necessity of creating livable conditions on a planet with distinct characteristics, the development of both technology and infrastructure would have been focused on addressing these crucial aspects. From the earliest stages of Martian existence, the refinement of intricate life support systems would have stood as a pivotal achievement. Navigating the Martian atmosphere's composition and the scarcity of resources like liquid water, the native Martian humans would have naturally pioneered advanced techniques for recycling air and water. This ingenuity would ensure a sustained supply for both respiration and agriculture. The establishment of self-sustaining ecosystems, adept at converting waste into valuable resources, would stand as a testament to the remarkable advancements of Martian technology. Crafting secure and adaptable habitats amid Mars' demanding conditions would have driven innovations in construction materials and methods. With structures designed to endure temperature fluctuations, the planet's low atmospheric pressure, and potential dust storms would have inspired architects and engineers to collaborate in order to devise effective insulating materials, radiation shields, and modular construction approaches that harmonized with the evolving needs of the evolving Martian society. Given the limited resources inherent to Mars, self-sufficiency would be an intrinsic goal woven into the fabric of Martian society. Evolved to master their environment, Martian humans would have perfected techniques for extracting and utilizing resources from the planet's surface. These methods would include mineral extraction, tapping into subsurface ice reserves for water, and leveraging local materials for construction. Advanced robotics and automation would seamlessly integrate into these resource extraction processes, compensating for the challenges posed by the Martian landscape. Although interplanetary travel may not mirror Earth's historical role, the efficiency of traversing between Mars and its moons, Phobos and Deimos, would still be vital for linking diverse Martian settlements. The continued development of propulsion systems bridging this gap holds significance. Furthermore, the evolution of communication technologies becomes crucial to facilitate real-time interactions across the expanse of these varied Martian communities. The settlement of Mars might have nurtured a culture of interplanetary collaboration, diverging from the competitive nature often seen here on Earth. Given the relatively shorter distances to other celestial bodies with potential habitable conditions compared to the span between Earth and Mars, the focus could shift towards forging relationships with any intelligent entities inhabiting those distant worlds. This perspective could naturally cultivate a cooperative ethos within the realm of space exploration, fostering joint endeavors in the pursuit of mutual scientific enrichment. In the next video, we will delve into social aspects on both a planetary level and an interplanetary level. Stay tuned and subscribe to ensure you don't miss it.